All right, welcome. This is chapter 2, section 1, conditional statements. All right, this is a whole chapter is on what we might call logic and reasoning. Okay, so you might think, well, what does that have to do with math? Well, it's very mathy. In fact, we define logic and reasoning by the use of what we might refer to as conditional statements. Okay, as you can read, a conditional statement is a logical statement that has two parts: a hypothesis, what we might refer to in math as P, and a conclusion, what we refer to as Q. Right? They're often written, in English as an if-then statement. Okay, if the hypotenuse of a statement, and then the conclusion part of the statement. Right. So in words, we might say if P then Q. Right. Symbolically, when we use algebra and math symbols, we use an arrow. Okay, so P becomes Q. Right. That's another way of saying that whatever P is assuming, Q happens, right? For example, here's a conditional statement. You are in Texas if you are in Houston, right? It could be rewritten as if you are in Houston, then you are in Texas. All right. Now, there are different types of conditional statements. There's our regular conditional if then statements, right? And then there's what we call the negation statement. That is to say, if P happens, then not P. Okay. If P happens, then not P. A converse statement would mean the hypotenuse and conclusion are switched. All right. In other words, if Q, then P. We'll go through some examples here in a little while. An inverse statement, okay, is more what we might consider the negative, right? In other words, if in a conditional statement, we might say something like uh, if you are in Houston, then you are in Texas. Okay. An inverse would get that backwards, right? If you are not in Houston, then you are not in Texas. Okay. Now, right now, we're not dealing with the truth of these statements. We're dealing with the parts of the conditional statements, the hypothesis, and the conclusion. Okay. One more different type of conditional statement is called the contrapositive statement, and that's when they're both negative, right? In other words, if you are not in Houston, then you are not in Texas. Okay. Now, on occasion, these are may or may not be true. Once again, these are just ways of organizing information in statements. They do not speak to the truth of the matter. However, when you think about the words that we're saying, we do on occasion come into a situation in which both the conditional if then statement and the converse statement are both true. Okay. In which case, we would use the phrase if and only if. Okay. Now, we often abbreviate if and only if, right? In other words, if and only if you are in Houston, then you are in Texas, right? Might be a way of phrasing that. Now, we use IFF to shorthand if and only if. And as a symbol, we use a double-headed arrow, right? In other words, it's the same arrow of action, but going both ways. All right. So let's take a quick look at today's work and some examples. Maybe some of this will start to make sense to you. Okay. For example, it asks us here to rewrite the given definition as a biconditional statement, right? So here's our definition. If two lines intersect to form a right angle, then they are perpendicular lines. We identify our hypothesis and our conclusion, right? Our hypothesis, P, is if two lines intersect to form a right angle. Okay. Oftentimes we can find the hypothesis because we usually use the English word if right in front of it, right? Because the word if already tells us it's going to be one or the other. There's an outcome that has not yet been reached yet. Okay. Q will be our conclusion because that's what happens if this P part happens. In other words, our our um, our conclusion is they are perpendicular lines. Excuse me. Okay, just had to sneeze there for a moment. All right. Next, our statement, therefore, PQ, if P comes Q, if two lines intersect to form a right angle, then they are perpendicular lines. And of course, the converse way of saying it, right, the Q and then the P, if they are perpendicular lines, then two lines intersect to form a right angle, right? Since both of these are true, okay, both this top statement and the bottom statement, P to Q and Q to P, since they're both true, we refer to this as a biconditional statement, okay? It works both ways. And with that in mind, we use this symbol. P is action to Q, okay? So here's our statement. Two lines intersect a right angle to form a right angle if and only if they are perpendicular lines, okay? We reach this English conclusion because we reach the logical conclusion. We reach this logical conclusion based upon our understanding that which one is our premise, which one is our hypothesis, and which one is our conclusion, okay? Once we see both those statements are true, going both directions, either way you look at it, we can go ahead and conclude this is a biconditional statement in which the words if and only if are valid. Okay, now let's take a look. On the back, daily exercises. Identify the hypothesis and conclusion. Okay, so I'm going to ask you to write it out, but for time's sake here, I would just like to point out to you, if you like math, that's our hypothesis. Then you like science, that's our conclusion. Alrighty? That's what we're doing here. That's what we're asked to do. Can you tell which one is which? Okay. Here's another one. If you run, then you are fast. So our assumption, our premise, our hypothesis is if you are running, and the result of that action taking place would be Q. Now, once again, that's not a true statement, right? If you run, then you are fast. You might run slow, but that's not what they're asking you. We get bogged down sometimes as human beings into trying to figure out right or wrong or true or false. But that's not what they're asking us to do here. This is not based on true or false. True or false already comes from our own experiences. And because this using reasoning means we're using logic and not our experiences, okay? We do not automatically eliminate something just because it's not true. Now, we know it's not true, but we still need to identify that's the hypothesis and that's the conclusion. Here's another one. Rewrite the conditional statement in if-then form. When glaciers melt, the sea levels rise. Okay? So that's a statement. Okay? And I'm going to rewrite it if, and then my P, right? If glaciers melt, that's my P, then sea levels rise. Okay? And that's my Q. That's how we do that. We're going to rewrite it. We just took the same sentence, the same statement, but we made an if-then statement for it. Okay? Now we can go in reverse if we wanted to. We're not doing that for this question. But now we can go in reverse and figure out whether it is in fact biconditionals, right? Meaning, this is true. If glaciers melt, then sea levels rise. So let's reflip it around and see if that's true. If sea levels rise, does that mean that glaciers melt? The answer is no. There are other reasons why sea levels might rise that has nothing to do with glaciers melting, but so for that reason, we cannot make it biconditional. One's true and one's not. Now, it says here, write the conditional statement, PQ, the converse, the inverse, and the contrapositive in words. Okay, so let's take it one at a time. Conditional statement means if then, right? So if two angles are supplementary, and I know I'm writing small, but I'm just writing this down, right? So this is my Q. Then the measures of the angles sum to 180. Okay, so that's my Q. All right. Now, this is what I would call my conditional statement. Now they're also asking for the converse, right? So what does that mean? In our converse statement, we simply switch the directions of our hypothesis and conclusion. If the conclusion, then the hypotenuse. Okay, so let's write that down. Converse. If the measures of the angles, if my Q, then two angles are supplementary. Now I'm just doing this shorthand so we don't waste too much time here. Okay, but that's what they're referring to as converse, right? Just to kind of wrap up this idea here, what do they mean by inverse? Okay, let's go back over here. What do they mean by inverse? Inverse means if not P, then not Q. Okay, so here's our P and there's our Q. So if two angles are not supplementary, okay, that's my not P, then the measures of the angles do not sum to 180, right? And that's my not Q. Alrighty. So take a look at contrapositive. Okay. It gives you an example about how to put the contrapositive, right? Basically, it's the same as inverse. We're just switching the terms back and forth. Give that a shot. And if you have any questions, go ahead and ask me. Come to tutoring, or be sure to ask somebody else. Thank you.